Welcome to Lionheart Academy. My name is Richard Tai. Today we're starting a new lesson on trigonometry. We are continuing our lessons on trigonometry. So today is lesson 46. We have been on this for a while, and for the past few lessons we've been studying different formulas, different equations, sum and difference formulas, double angle formulas, half angle formulas. Then we use that to derive product to sum and sum to product formulas. So I think those are the most commonly used formulas. We're going to be using them. So today we're going to do some examples involving those formulas. Okay, so now we did proving identities before using basic identities only. But here, let's go ahead and try to take a look at some problems that's a little bit more involved. It will require us to use all the formulas that we may know, okay, from what we have learned to this point. So, for example, let's go ahead and take a look at this. Alright, so this is an identity. Okay, it's not just an equation, but it's an identity here, and we want to show that this left hand side is equal to the right hand side, that this is true. We know it is true. Okay, right, so it says sine of theta minus phi divided by sine of theta plus phi is equal to cotangent theta phi minus cotangent theta divided by cotangent phi plus cotangent theta. Just like what we did before. So just like what we did before, we want to go ahead starting with the more complicated side. Alright, and I'm going to draw a little divider here in the middle so we can go ahead work on both sides, left hand side and right hand side. Alright, I'm going to start with the left hand side because the left hand side can be simplified a little bit more readily than the right hand side. Well, we can do that too, but it's always easier to expand the sum and difference here. You can see that they're the sum and difference formula. So we're going to expand them very quickly here using the sum and difference formula. So sine of theta minus phi is sine theta cosine phi minus cosine theta sine phi. Okay, that's the first, that's the numerator. The denominator is going to be sine theta cosine phi plus cosine theta sine phi. So got to remember the formulas correctly, remember the signs. Alright, now this looks like a very complicated situation here. How do we go ahead and go about simplifying this? Well, look at this. Our result is in cotangent, right? So we're calling cotangent, but cotangent is equal to what? Cosine over sine. Now we do have some cosine here. We have cosine in different ways, but we don't have sine. So what we can do is we can divide both numerator and denominator by sine theta and sine phi. So what we do is we multiply. Basically, we're multiplying or dividing 1 over sine theta sine phi. Okay, and then we multiply this to the numerator, and we multiply 1 over sine theta and sine phi to the denominator as well. Okay, so let me go ahead and show you what will that look like. So it will become sine theta cosine phi divided by sine theta sine phi minus cosine theta sine phi divided by sine theta sine phi. Okay, and then the denominator will be sine theta cosine phi divided by the same numerator, denominator, sine theta sine phi plus cosine theta sine phi divided by sine theta sine phi. Alright, so now we can take a look at what we can cancel out. As you can see, the sine theta here in this part cancel out, the sine phi here cancels out, sine theta here cancels out. On the last fraction here, sine phi cancels out. And as we can see, cosine divided by sine is equal to cotangent, right? So we can simplify them into cotangent phi minus cotangent theta divided by cotangent phi plus cotangent theta. So there we go. We proved the left hand side and the right hand side are equal. Okay, cotangent phi minus cotangent theta divided by cotangent phi plus cotangent theta. Okay. Alright, so let me go ahead and use this side of the board here, this side of the screen. Let's do another example here. Example 2. Let's call that example 1. I'm sorry. Alright, so let's show this identity. Let's prove this identity is true. Tangent A plus cotangent 2A equal to cosecant 2A. Alright, so as you can see now, this one involves a double angle formula. Okay, now we're gonna start from the left hand side. Left hand side is more complicated. Alright, tangent A and cotangent 2A. Now we have not talked about the double angle formula for cotangent, because this is simply just the reciprocal of tangent of 2A. So we're gonna use this to start off. Okay, now let's remember what was the formula for the tangent of double angle. Tangent A, so it's gonna be 2 tangent A divided by 1 minus tangent square A. Remember that? Okay. So this is 1 over this. Now remember, when we have you divide by a fraction, is just the reciprocal of this. So this becomes 1 minus tangent square A divided by 2 tangent A. All right. So now we want to combine the. We like to go ahead and combine the fraction here. So the denominator here is going to be, should be 2 tangent A, right? But right now it's 1. So what we need to do is we need to make sure the first fraction also has the denominator of 2 tangent A. So I have to multiply by let's see, tangent A. 1 plus tangent square A. Yeah, let's go ahead and multiply this by the tangent A in the denominator. Okay, numerator, and tangent A in the denominator, but actually I need to multiply by 2. Yeah, 2 like that. So this will become 2. Oh, I'm sorry, change the color back. Let's go ahead and change this. Now this becomes 2 tangent square A. Now both fractions has the same denominator, which is 2 tangent A. Okay, now we're going to combine the numerators. Plus 1 minus tangent square A. Okay, so 2 tangent square A minus tangent square A becomes 1 tangent square A. So this becomes 1 plus tangent square A divided by 2 tangent A. So we're making a little progress here. Okay, we're making a little progress. Alright, let me go ahead and extend it down a little bit. Okay, alright, so let's see what we can do here. Now, 1 plus tangent square A. Oh, I recognize that. That's secant square A. That's right, that's secant square A divided by 2 tangent A. Okay, and let's go ahead and combine secant and tangent. Let's convert secant and tangent to cosine and sine, so we can go ahead and work this out. So this becomes 2 sine A over cosine A. Alright, so this is a complex fraction. Again, when we divide fractions, we multiply by its reciprocals. Okay, reciprocals. So we multiply by cosine A divided by 2 sine A. Alright, so as you can see, one of the cosine factor cancels out. So it becomes 1 over 2 sine A cosine A. And I remember 1 over 2 sine A cosine A is equal to 1 over sine 2A, which is sine of double angle, right? Sine 2A equal to 2 sine A cosine A. So you gotta keep maybe a cheat sheet. If you cannot remember the formulas, you gotta keep a cheat sheet next to you. And what's 1 over sine A? 2A, I'm sorry. The reciprocal of sine is cosecant. So it is cosecant of 2A. So we worked the long way, and then we did prove that the left hand side is equal to cosecant of 2A. So that's using all the knowledge that we have about all the formulas that we had. Okay. Now, of course, you won't be able to. Maybe you won't be able to get it right the first time, but there are more than one way to do this. You can start from both sides. You could try to simplify the left hand side, the right hand side as well, and see if you can meet in somewhere in the middle. That's another technique. But also, this just comes with practice. You need to have different practice, and then sometimes it takes a trial and error to play around with the expression a little bit to see if you got nowhere. Then go ahead and go back and try to start over again. It will take some time, but I think this is a good practice. This is a good practice in applying those formulas. And why do we need to do this again? Is because different times that we have different formulas and different expressions that we need to convert them to different forms. Especially when you later on go into calculus and more advanced mathematics. When you do integrations and derivatives, sometimes it's easier to do one in one form than the other. So it will require you to use trigonometry identities to simplify those expressions. Alright? So let's go ahead and try another example here. This one may be a little bit easier here. If you can recognize, the key is recognize what kind of formulas that we're looking at. Okay? So this is equal to tangent alpha. Alright, now it doesn't look like it's looking to equal to tangent alpha at this point, But let's go ahead and take a look at this. Sine 7 alpha minus sine 5 alpha. Now that does reminds me of the sum to product formula. Okay, sum to product. So this is a sine of an angle minus a sine of another angle. So let's go ahead and go back to the sum to product formula. So that tells me it's going to be equal to 2 cosine of half of their excuse me, half of their average. So you add them, divide by 2, and then this is going to be sine of half of their difference, 7 alpha minus 5 alpha divided by 2. Okay, so that's the top. Now the bottom is the cosine 7 alpha plus cosine 5 alpha. That's also can be used. We can also use the product to sum. Sum to product formulas on this. Sum to product. So it's going to be 2 times cosine of 7 alpha plus 5 alpha divided by 2 divided by cosine of 7 alpha minus 5 alpha divided by 2. Okay, so alright, then we can go ahead and just take a look. Well, this 2 cancel out with 2 cosine of the same thing. This is actually 6 alpha. Cosine 6 alpha divided by cosine 6 alpha, they're the same. So here we have left is sine of 7 alpha minus 5 alpha is 2 alpha divided by 2 sine alpha divided by cosine alpha. Yeah, and then that indeed is equal to tangent alpha, because sine divided by cosine is equal to tangent. Alright, so we have proved we have to prove this is true using the product to sum formula. Okay, sum to product formula. I'm sorry, keep saying the wrong thing here. Now there are other examples. Let me go ahead and show you another example using this, the formulas that we have learned. Okay, example number 4. Alright, let's try a half angle formula here. Tangent theta times tangent theta divided by 2 equal to secant theta minus 1. Alright, so let's take a look at this. So this is a half angle formula. Now remember, half angle formula, there are several ways I can write this. I can write it as sine, okay, tangent of theta over 2. I can write it 1 minus cosine theta over sine theta, or I can write it as sine theta over 1 plus cosine theta. So let's go ahead and use I'm not sure which one we should use, but let's try. Let's just go ahead and use the first one. So let's write this as 1 minus cosine theta divided by sine theta. Let's use this one and see what happens. Okay, so supposedly it's going to be equal to secant theta minus 1. Now tangent theta is sine theta over cosine theta. So I think now maybe you can see the reason why I use 1 minus cosine theta over sine theta instead of the other one, because I probably can still work out if I use the other one, but here I can see that sine theta and sine theta cancels out much easier. Okay, so it will be 1 minus cosine theta divided by cosine theta. Okay, divided by cosine theta. Alright, so now how does this become that? Well, I actually have two fractions. The denominator is cosine, the numerator, there are two numerators, so I actually have two fractions. And once I separate them, I can see very clearly 1 divided by cosine is secant, and cosine minus sine, cosine is 1. So we have proved that this too is true. So we just use this half an angle formula. Alright, so let's go ahead and try another one. Sorry, that was not example 6. This is example 5. Alright. Sometimes it's a little bit hard for me to write with the system here, but it's been working pretty well for us. Alright, so let's take a look at this. Cosine 4 to the power a minus sine to the 4 to the power a equal to cosine 2a. Now, we remember this is not the double angle formula. The double angle formula actually is cosine square a minus sine square a squared, not 4th power. So what do we do is that? Well, if you recognize that this is the difference of squares, you can always factor differences of squares. So this is cosine square a times minus sine square a times cosine square a plus sine square a. Because when you factor difference of squares, that's what you're going to come up with. Okay, this product of difference and sum. Okay, that's a basic algebra technique. And after that, you can recognize that cosine square a plus sine square a is simply equal to 1. So this is simply cosine square A, I forgot A, minus sine square A times 1, because by Pythagorean identity. And then cosine square A minus sine square A is equal to cosine of 2A. So this is a pretty straightforward one. Okay. Alright, so I think today we did a few examples and we showed you all those formulas in action, and there are other things that we can do. We can solve system equations, not system equations, we can solve equations, trigonometry equations as well, but we'll go ahead and try one example like that, solving the equations. For example, let's do sine of 2 theta equal to 2 sine theta. Okay, so let's see how we can solve this. Alright, now so sine 2 theta, let's go ahead and simplify this first. This becomes 2 sine theta cosine theta equal to 2 sine theta, right? Now we don't want to cancel out the 2 sine theta on left hand side, right hand side. I mean, it's tempting to do that, but if we do that, we will lose solutions. So we don't want to do that. We want to move them to the same side. So we want to go ahead and do 2 sine theta cosine theta minus 2 sine theta equal to 0. We want to do that, and then we want to use factoring form. So let's factor out the 2 sine theta. So this will become cosine theta minus 1 equal to 0. So that was a big key here. We don't want to cancel out the 2 sine theta on both sides. Otherwise, you will lose a solution because I'm sorry, I went back up. You will lose the solution. So this is the correct approach, is to move the 2 sine theta to the same side and then use factoring to solve this. We always want to use factoring to solve, because factoring will help us get all the answers, possible answers. So 2 sine theta times cosine theta minus 1 is equal to 0. That means the two factors has to be equal to 0. Alright, so let us go ahead and set them equal to 0. So sine theta equal to 0. So that means theta has to be equal to 0. Okay, if we are solving for 0 or 2 pi and 0 and pi, and then 2 pi and so on. Alright, so the answer keeps going. Now if we're solving just for the answer between 0 and 2 pi, then we will stop right here. Otherwise, we have to write the general solution. Now let's move on to here. So cosine theta equal to 1. Now when does cosine theta equal to 1? Well, when theta equal to 0. Okay, that's the only case, and 2 pi. So if we're looking for the solution between 0 and 2 pi, the answer would just be 0, pi, and 2 pi. Actually just 0 and pi. But so let's write the general solutions, because the period is 2 pi, so we would just basically write 0 plus 2m pi, okay, and pi plus 2m pi, and that's it. So those will cover all the solutions. Now m belongs to the set of all integers. Again, m belongs to the set of all integers. And I'm trying to write a boldface z. It's not very easy like that. Okay, so that's a boldface z indicating the set of all integers. So n can start with 0, 1, 2, 3, or 0, negative 1, negative 2, negative 3, and so on and so forth. So those will cover all the solutions. Alright, okay, so let's try another one. The sine of 2x equal to cosine of 3x. Alright, so here it looks a little bit weird because we have a double angle formula and 3x, a triple angle, but we have never done any triple angle formulas before. Well, let's go ahead and see how we can do it. First, let's go ahead and bring them over to the same side and set equal to 0. Okay, and we want to use for 3x, we cannot use direct formulas, but we can go ahead and use sum and difference formulas. The sum and difference formula, we can use that to expand this. So this will become sine 2x minus, this is going to be cosine 2x cosine x. The original formula is negative, but there's a negative in front of it, so it's going to change that to a positive. Positive sine 2x sine x, okay, equal to 0. So as you can see, we will not be able to factor this because they don't have enough common factors in all three of them. Right, so let's go ahead and break everything up. So this is sine 2 sine x cosine x by using the double angle formula. Cosine 2x, let's go ahead and break that up. Now there's 3 ways to break cosine of 2x. So which way should we use? Should we use the sine way, sine only, or the cosine only formula, or use sine and cosine formula? I think we should use one of the sine only formulas. Let's go ahead and use that and see how where can we go from there. Alright, sine of 2x. Again, sine of x is 2 sine x 2x, but there's another sine x, so this becomes sine square x cosine x equal to 0. Okay, so let's open this up. So I have 2 sine x cosine x minus cosine x minus 2 sine square x cosine x plus 2 sine square x cosine x equal to 0. Okay, alright, so let's go ahead and see what we can do. Now, the 2 sine x plus, let's see, 2 sine square x. Is there anything that we can cancel? Oh, this is actually a plus sign. I'm sorry. This is negative cosine plus 2. Okay, so this becomes 4. Let's go ahead and write this down. So 4 cosine square x cosine x. Alright, plus 2 sine x cosine x minus cosine x. Alright, so now you may be thinking that this is very complicated, but if we sit down and take a look at this, there's a cosine x, first of all, in all three of them. So we can factor out that cosine x, and after we factor out the cosine x, we actually see that this is an equation in a quadratic form. Do you see the quadratic form here? Sine square x plus sine x minus a number constant, so sine to the second power, sine to the first power, and sine to the 0 power. So this is a factorable. Either this is factorable, or we can go ahead and solve it using quadratic formula. Okay, so that means we're going to separate these two things now. Now we can go ahead and set cosine x equal to 0. So that's easy. We can look at the unit circle to determine when does cosine x equal to 0. So cosine x will be equal to pi over 2 and 3 pi over 2. Alright, and so the rest of it is 4 sine squared 2x, sine squared x plus 2 sine x minus 1 equal to 0. So let's go ahead and use quadratic formula to solve it, because I don't think this is factorable. Okay, 4 and 1 cannot make a 2 here. We won't be able to do that. So let us go ahead and use our quadratic formula. So we use sine x equal to negative b, so it's negative 2 plus minus square root of b squared, which is 2 squared, minus 4 times a times a is 4, I'm sorry, and c is negative 1, divided by 2a. Okay, so let's simplify this. This will become negative 2 plus minus square root of 4 plus 16 divided by 8. So let's simplify that. This will be negative 2 plus minus square root of 20. So square root of 20 is 2 square root of 5 divided by 8. So we can reduce everything by 2. So it's negative 1 plus minus square root of 5 divided by 4. Alright. Now, so what do is this, we convert that to a decimal. We can convert that to a decimal, or we can just leave it like that. But now we have to solve for x by using cos arc sine. Okay, we're going to do arc sine of negative 1 plus square root of 5 over 4. Okay, and we're going to do arc sine of negative 1 minus square root of 5 over 4. So we will be able to get two answers. So I'm going to get the answers in radian. Okay, let's go ahead and take a look at that. So negative 1 plus square root of 5 divided by 4. Now if we do arc sine, we will get 0.3141, approximately 0.31442. Now this is in first quadrant, right? But arc sine also will be true. If it's positive, it will be true that it's going to be in first and second quadrant. So there's another angle in second quadrant that we need to look for. So we know that this is in quadrant 1, and we have to find another angle in quadrant 2. Okay, so let's go ahead and look for that angle in quadrant 2. How do we look for the angle in the same angle in quadrant 2? Well, it's the reference angle that we're looking for. So we are going to use pi to subtract this. Pi to subtract this number. Okay. Excuse me. So when we use pi to subtract this number, we'll get approximately 2.8274, because this is the reference angle of the same angle in quadrant 2. So in quadrant 2, it will be 2.8274 radian. Okay, now let's go ahead and do the arc sine of the -1 minus square root of 5. So -1 minus square root of 5 divided by 4. Okay, let's do the arc sine. So this will be a negative 0.9425. Alright, but let's go ahead and represent this is in fourth quadrant, so we're going to represent this using a positive angle. So we're going to add 2 pi to there. So let's add 2 pi. So this is 5.3407. Okay, 5.3407. Alright, so that's what 2 pi this angle is. But there's another angle. This is in quadrant 4, right? There's another angle in quadrant 3. There's another angle in quadrant 3 that is the same as this angle. So we need to find that. Now, how do we do that? Well, if I go ahead and draw a little picture here, maybe we'll show you. So this is negative 0.94, right? Alright, so this was 0.31. And this is 2.82. So we know there's another angle here, that this space here, this is negative 0.14. So that means coming from here is negative 0.14. That means going down here also should be a negative 0.94. So this space is also going to be 0.94. So what we're going to do is I'm going to use 2 pi. I'm going to use 1 pi actually. This is pi. So 1 pi. Now let me go ahead and do I'm going to do arc sine here again. I'm going to get the negative 0.9425, this number again, and then I'm going to change to positive and add it to pi. Alright, so it will be 4.084 407 yeah, 0.0841. Okay, so 4.0841. Alright, so if I convert this to degrees, I think, let's see, if I convert this to degrees, 4.0841. If I convert that to degrees, I multiply by 180 divided by pi. It's 234 degrees. Yes, so that's correct. So this is 234 degrees. This is 306 degrees. I think this is 18 degrees, and this should be 162 degrees. So we can verify that. So there are 4 angles. So altogether, we have this is 0 degrees. This is 90 degrees, and we have 270 degrees. So altogether, between 0 and 360 degrees, we have 6 solutions. All right. So again, this is a way at how we approach this kind of situations. All right. So if you have any other questions, or if you have any different kind of questions from your homework or from your other teachers in different school, different classes, you're welcome to post on the comment sections, and then I'm more than willing to go over those kind of questions on the video and then help you with all your homework problems. So if you have any other questions on different things that I didn't cover, you're welcome to ask. We look forward to helping you with in any way that we can. Alright, thank you for today. This is a long video, but we hope to see you next time, and join us next time on our next lesson. We're going to start with solving oblique triangles, the law of sine, law of cosines in our next lessons. Alright, bye bye.